Let's look at some examples where we are going to use the power, sum, and difference rules to differentiate each function. Let's look at our first example. Our function is 2x cubed minus 3x squared minus 4x. Our derivative can be written as f prime of x is equal to the derivative with respect to x of 2x cubed minus 3x squared minus 4x. We are going to take the derivative of each piece, and whenever we have a constant, we can just pull that constant out in front of the derivative. So our first piece looks like this. It's 2 times the derivative with respect to x of x cubed minus 3 times the derivative with respect to x of x squared minus 4 times the derivative with respect to x of x. Now we're going to take our derivatives. Our first piece has 2, and then the derivative of x cubed is 3x squared. You just subtract 1 from the exponent, minus 3 times the derivative of x squared, which is 2x, minus 4 times the derivative of x, which is just 1. We can now write our answer as 6x squared minus 6x minus 4. When you get used to doing this, you can probably just write that answer down without going through any of these in-between steps. Let's now look at our second example. We are going to take the derivative of y is equal to x squared plus 4x plus 3, all divided by the square root of x. To use the power rule, we need each term in this function to be raised to a power, and we can't have a denominator. So let's start by rewriting this function and get rid of the denominator. This gives us y is equal to x squared divided by x to the 1/2 plus 4x divided by x to the 1/2 plus 3 all divided by x to the 1/2. We can split this up because we only have one term in the denominator. Let's now rewrite this. This is y is equal to x to the 3/2. I got that because we can think of 2 as 4 divided by 2, and then we just took 4 and subtracted 1. And then for our next term, we have 4x to the 1/2. This is just 1, and then we subtracted a half. And then our last term is 3x to the minus 1/2, just bringing that 1/2 up on top. Now we can go ahead and take our derivative. Our derivative is dy dx, and it is the derivative with respect to x of our first piece, x to the 3/2, plus our derivative with respect to x of our second piece, 4x to the 1/2. And then lastly, in our third piece, there is a 3 sitting there. We can pull that out in front and then multiply that by the derivative with respect to x of x to the minus 1/2. We could have also pulled out the 4 in the second term. Now we can take the derivative of all 3 pieces. Our first derivative is 3/2 x to the 3/2 minus 1. And then our next piece, we pull out the 4, and then we take the derivative, which is 1/2 x to the 1/2 minus 1. And then our last piece, we're going to take our 3, multiply it by minus 1/2. So we get minus 3/2 times x to the minus 1/2 minus 1. This then gives us 3/2 x to the 1/2 power plus 2x to the minus 1/2 power minus 3/2 x to the minus 3/2 power. Now, it looks like we could be done, but notice, let me pull this back down. Notice in our original problem, we had a square root of x. So that kind of clues us in that our answer needs to be in terms of square roots and not just in terms of x to the 1/2. So I'm going to rewrite this as 3/2 times the square root of x plus 2 all divided by square root of x minus 3 all divided by 2, and then x to the minus 3/2 becomes x to the 3/2 when we put it in the denominator, and then x to the 3/2 can be written as x times square root of x. Let me just make a note over here so this is clear. This is 1 over x to the 3/2, which we then wrote as x times the square root of x. And there is our final answer. The last example that we are going to look at is an application example. In this example, we are going to find equations of the tangent line and the normal line to the curve y is equal to 2x cubed minus x squared plus 2 at the point 1, 3. I'm going to start by finding the equation of the tangent line, and let's go ahead and let's write down what that equation looks like. That equation looks like y minus y1 is equal to the slope times x minus x1. The first thing that we need to do is find the slope. So the slope of our equation is the slope of the tangent line to the curve, and that is given by dy dx. And we want to find that at the point 1, 3. So that means x is equal to 1. So I'm just going to put down x is equal to 1. So what we're doing is we're finding the derivative at the point x is equal to 1. Let's write down what our derivative is. That is going to be the derivative with respect to x of 2x cubed minus x squared plus 2 evaluated at the point x is equal to 1. This is equal to 6x squared minus 2x, and then the derivative of 2 is 0. And we are going to evaluate this at x is equal to 1. So this becomes 6 minus 2, which is 4. So our slope is equal to 4, and we can plug that into our equation. We are given that x1 and y1 is the point 1, 3. So we can write this as y minus 3 is equal to our slope, which is 4 times x minus 1. Now, it's always nice to write this in slope-intercept form. So I'm going to bring the 3 to the right and multiply things out. This gives us y is equal to 4x minus 4 plus 3. And this gives us an answer of y is equal to 4x minus 1. And that is the equation of the tangent line to our curve at the point 1, 3. Now let's look at the second piece of this problem. We want to find the normal line. The normal line is perpendicular to the tangent line. So the slope of the normal line is going to be the negative reciprocal of the slope of the tangent line, which is minus 1 over m. So it's going to be minus 1 over m, which was 4. Now we do the same thing. Let's write down our general equation. Y minus y1 is equal to our slope. We'll go ahead and put in minus 1/4 x minus x1. Now we're going to substitute in that y1 is 3, x1 is 1. So this gives us y minus 3 is minus 1/4 x minus 1. Now let's multiply everything through. This is y is equal to minus 1/4 x plus 1/4 plus 3. Let's think of our 3 as 12 over 4. So our final answer is y is minus 1/4 x plus 12 over 4 plus 1 over 4 is 13 over 4. And let's highlight this because that is the equation of our normal line.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.